Welcome to the NCGE webinar series for the 22-23 school year. My name is Julie Wakefield, and I'm the Professional Development Coordinator and Resource Specialist for NCGE. The National Council for Geographic Education believes that geography education is a bridge to a better understanding and appreciation of all subject matters. NCGE is a nonprofit organization that's committed to ensuring that all students graduate with the knowledge, perspective, and skills to make informed decisions as they go through life. They support all educators in their desire to create engaging, authentic, inquiry-based learning experiences for students at all ages. For tonight's webinar, we've partnered with the Institute for Middle East Studies at George Washington University. This is the second of 4 webinars we have planned for you. First, tonight, we're going to have Shana Marshall talk about some opportunities that they have available to teachers for creating teaching materials from this webinar series. Then after our speaker tonight will join us, Danielle Katz, who's a senior studying geography and GIS. She's interested in open source software and collective data management, especially in issues of land and food sovereignty. This webinar will demonstrate basic geoprocessing tools and cartography using open source software, which there's a link in the chat for you to access that, and data to map the inadequate provisions of infrastructure in the West Bank. Please feel free to use the chat with questions, and we will get to those after the presentation. So first, I give you Shana Marshall.
Hello, everyone. Thanks so much, Julie. And thanks so much, Julie, for working with us on this. My name is Shana Marshall. I'm the Associate Director of the Institute for Middle East Studies at George Washington University. And we have a grant from the U.S. Department of Education to do programming geared toward K-12 teachers on the Middle East. So as part of that, we partner on this webinar series. We also have developed some materials that you would probably also be interested in. The link is in the chat for that. That's the IMES Merit Public Outreach Partnership, or MPOP. And that has some really cool maps and interviews with activists and scholars and editorial cartoons and infographics and lots of stuff on different issues like environmental justice in the Middle East, fracking, anti-fracking protests in Algeria, and lots of other super cool stuff that your students will probably be interested in. And we also have funding to support the development of curriculum materials. So if you or any of your colleagues, educator colleagues, are interested in developing curricular materials around any of the webinars that we do in coordination with NCGE, we have funding to provide a $500 honoraria for the development of those materials. If you're interested in that, you can send an email to, and I will put it in the chat, this email address. It stands for the National Resource Center of the Institute for Middle East Studies. If you want to just send us 3 to 4 sentences about sort of the nature of the material that you want to develop curricular materials on around the webinars that we've done so far. And I'm going to go ahead and put also the IMES YouTube page in here, because the recordings of these webinars are also up there as well. Shoot us an email and we'll go over those. We'll look through those in the next few weeks and get back in touch with the folks we want to follow up with. Thank you guys so much for attending tonight, and thanks so much, Danielle. I'm really looking forward to this. And you can always drop us a line at that email if you have any interest in our other teacher resources or other programming around K-12 outreach on the Middle East. Thanks very much.
Okay, Danielle, it's all yours. Thank you for being with us tonight.
Of course, thank you all. So as we said, my name is Danielle. I'm a senior at George Washington University. I'm in DC right now. And I'm here to just show you some basics of, data download and how to create cartography and what a basic outlook of cartography should look like. And there is a link for the QGIS data download in the chat. Can everyone see that? I will demo it later on, but if you feel confident in your ability to like download Python and then download QGIS with those written instructions, feel free to have that loading in the background. If not, I'll come back around to it. And then, oh, I guess I can just check the chat. Okay, great. So it is in there. Okay. So just to get started, so this is an example of what a map could look like with the data that we're using. This is an example of proximity of clinics and hospitals to firing zones in the West Bank. And I'll get into what all of that might mean and how to do intentional layout of the key and this metadata at the bottom, which is essentially your date, your name, and the sources that you're using, as well as a scale bar, an accurate north arrow, and how we can create a buffer zone, why we might want to create the buffer zone. And that will all be in the written instructions, which I'll send in later, that you can follow along with while I do a live demo. So first of all, we'll be using open source data and open source software. So what that means is that it is data that's freely available to everyone to use, modify, republish, as they wish for any purpose without any type of discrimination based on your qualifications to be using that data or based on copyright or any type of patenting. Common sources of data retrieval could be data from a city website, from a federal government organization, or pretty much a university, any type of place that does any type of research geographically. And you'll be able to download that file within a zip file that will give you an Excel sheet of the data with a bunch of different attributes about it, and a shapefile, which is what that data becomes when it has a geographic aspect to it and it has coordinates that can be plotted, and it's just called a shapefile. And then QGIS is the software that we'll be using. So it's a free open source cross-platform desktop geographic information system application that supports the viewing, editing, printing, and analysis of geospatial data. And we will be viewing, editing, printing, and doing analysis of that data. So the types of data you can download are point, line, and polygon data. So point data would be something that does not have a dimension other than an exact coordinate location. Line data would be something that has the dimension of length, and a polygon data would be something that has the dimension of area as well. So a few examples of this locally would be in Washington, D.C., for example. This is point data of the central location of all colleges and universities that are within the District of Columbia. So if it were to be the entire campus, that would be a polygon shapefile because it would have an aspect of area. But here's just a central location, so that's just going to be a bunch of plotted points. For line data, you can see that the pink line is the US-Mexico border, and where there's fencing is going to be gold. So already you can see that just layering two files on top of each other can start to tell a story. And that's what we did, or that's what we're going to do in the demo. But we will be using shapefile data of schools and military firing zones, as well as the background data of, the West Bank entire polygon to give some context. And then for polygon data here, we just have the Great Lakes of the US and Canada. So water bodies, unless it's like a really thin river, are usually going to be polygon data. And all of this was downloaded from either Open Data DC, which is DC's collective data database for different shapefile data, as well as like a Homeland Infrastructure from the government. And then we also have OpenStreetMap, which is where I got the polygon data. And OpenStreetMap is basically an open source version of Google Maps. So you can download that data and use it freely, whereas with Google Maps, you can't do that. So open source data can come from a city government, which we just saw, from federal government, which we saw with the Homeland Infrastructure, NGOs, and OpenStreetMap. And the shorthand for that is OSM. So the difference is that proprietary data, usually by Esri or any other sort of protected government data, is that it can cost a lot of money. So for example, for Esri, you would have to pay $100 a year for a personal account, or like $700 to $800 for like a professional account, which is obviously not very accessible. There's also protected data. So maybe that's if someone did research and they're not publishing their data for free. Or it could be because it is, oh, I see we have a chat. Oh, yes, exactly. Great. And then also protected data can be like for political reasons as well, which brings you to the question of if you can't find data, what might that mean? And that might mean that someone either doesn't want you to find it. It could mean that there's not enough funding in that location to do research and find pinpointed geographic data, because that does take a lot of work to create raw data. Oh, okay. So there we go. So once you have that data, we have something called an attribute table. So what that is it's an Excel sheet essentially, but it corresponds to your geographic data. And it shows the coordinates of your points, lines, and polygons. But once it becomes a shapefile, that's why we call it an attribute table, because it's showing the attributes of that shape. So the left isn't what we'll use, but it is a very clear diagram, and I'll send out the slides in the chat later, but I have hyperlinked it. It is from ArcGIS, but it was a free resource. And you'll see that there are options. There's going to be ways to select by attributes. So you could select certain locations in the table and see how they correspond geographically. And then, of course, you can use buttons to deselect or invert your selection and select everything that was opposite. And then on the right is what you'll see in QGIS, which I personally think has a much cleaner look. But you can see that for Israeli firing zones, I just right-clicked and I opened the attribute table, and I had all of these 24 locations show up, and it tells you a little bit about it. So one of the attributes could be its name. Perhaps in these data sets, some will have names in English, and then they'll also have names in Arabic. And then it has the length and the area of the shape. So the data that we'll be using comes from a few different sources, but I just want to give a little bit of background of what the context of the data that we're using is. So the West Bank is an occupied territory. They do have a government, which is the PLO, Palestinian Liberation Organization, but there is an occupation by the Israeli government that is illegal under international law, and it heavily limits resources, services, people, any sort of flow of resources. And there are many human rights violations. And I think what's unique is that maps and shapefile data can show these issues in a way that's much more concise than reading reports on human rights violations. So I think it's really unique. So the way that I found this data was you essentially Google exactly what you're looking for, because there is overall an abundance of geographic data out there. And then you look at shapefile. But the important thing with this type of highly politicized data is that you're taking it from really trusted resources. So for example, I have from Palestinian authorities, such as like the Ministry of Planning. I also have Ministry of Education showing schools. So they're always like appropriate. And as well as OCHA, which is the UN Office for Coordination of Humanitarian Affairs. So I've discussed the term firing zones multiple times now, and I just wanted to really go into depth before we start actually using that data and looking at how to manipulate it. So a firing zone is a closed area within the occupied West Bank that Israel has designated for military training for their army. So as of 2012, which was a little bit ago, but OCHA released a report that roughly 20% of the West Bank was occupied as a firing zone. And despite claims of military need, only some parts of it are actively used for military training, and some documents have come out and been released that they were also reserved as military training, but are now used for settlements, which is why I also linked some Israeli settlement data which we won't personally be using, but if you ever want to come back and revisit it, I was just making this chart with the hope that you can mix and match whatever data that you wanted to. So if you're in close proximity to a firing zone, you are considered among the most vulnerable. So they have extraordinarily limited access to services, including education and healthcare, which are the two that I highlighted. And there is like a bigger subjection to violent attacks from settlers. And we're going to look at the proximity of these critical infrastructure points, such as schools, in order to see the real radius of effects of living near one of these firing zones. So we will see that some schools, clinics, and hospitals are directly within the firing zone, but we'll also look at some excerpts from some articles to assess what a buffer zone that might not be recognized by law, but really does exist and really does affect people, and see the difference of how many clinics, hospitals, and schools are included within that real radius versus what is designated as a firing zone. And because it's such a highly politicized issue, maps are, again, very powerful because we're letting the data speak for itself. We have a scale bar and we have a buffer zone, and we have our metadata to show that this is well researched, and we can tell a story that's going to be easily accessible because it's essentially pictures. Okay, so now we can dive into some of the tools that we can use to display and manipulate this data. So we can use things like color to display data. There's basic elements of legends, scale bars, north arrows, and how we intentionally place them, as well as basic manipulation of creating a buffer zone, which you'll see once you get the hang of it, takes only 2 or 3 clicks to do and can be a very powerful tool. We'll also use a tool called the intersect tool, which I'll get into later, but it shows where there is quantifiable overlap between 2 sets of data. So that could be your point data of clinics and your firing zones or your buffer zone. So this is an example of a map that I created on the right to help illustrate some of my points that I'm going to be going through. So for example, for physical geography, we always want to be using blue for a water-related feature, and keeping things intuitive in order to have more integrity to our map and make sure that nothing is misleading. If you were going to be focusing even more on physical geography, you might see that brown is used for elevation numbers or contour lines. And then a great example of using intuitive symbology is the idea that green would be like really abundant vegetation features and white would be sparse or no vegetation. And if you were to flip those, it would no longer be intuitive, and the map would be harder to read, and therefore not send as good of a message. Another classic example would be a political map. So for the US, you would only really want to use red and blue for either like temperature or politics. Red being Republican and blue being Democratic. And you wouldn't want to flip those, or it could be really, really misleading, and could be easily misconstrued. And then as far as shapes, you really want to draw the eye to the point data because that's normally going to be your most important data. So for triangles, that could be something such as mountains, but it could also be something like tents or houses. Circular points are a lot better for showing just one type of item. And then we also have realistic symbols. So on the right, this was electric vehicle charging stations. And so we have that symbol on the right, and we have 2 different colors rather than 2 different symbols to show the same thing that would be funded by 2 different sources, so that you're really trying to declutter the map, but still create a clear image. And the best way you can do that is changing color. And then as far as shading, this is really helpful in showing that an area can relate to 2 different categories. So you can see that brown would be eligible with an AFV grant and IRA eligible and AFV eligible when there's overlap. And an example of how we might use that today is if you want to put your buffer zone as shaded or your firing zone as shaded. Okay, So once we have that data loaded in and we've sort of played with the colors, at first you might just want to play with the colors just to make it visible to yourself, because there are like random default colors that aren't always fantastic. You'll be able to explore your data. So you'll be able to select by attribute. So you can select through like what looks like number 1, where you can select the actual item that you're interested in, or you can select what looks like number 3 and select by geography. So you can select maybe just that point in the upper right corner, and then you can reopen the table to see what that corresponds to and learn more about that. I also showed some common icons, such as like delete selected features or invert selection, just so that you know what they look like, because it's not going to be written out and it's a nice little reference tool. Another thing that you can do in the data table is you can click on the like silver bar right above where the yellow is highlighted, and that will sort your different points, either ascending or descending, depending on if you click it once or twice. But instead of being in numerical order, because they'll all be attributed to just like a random number, just like 1 through whatever many data points you have. You can like, for example, for type, you could sort by hospital and all the hospitals would come first and clinic second, or you could click it again, it would be clinics and hospitals. So just to introduce the 2 geoprocessing tools that we'll use, and geoprocessing just means like a basic manipulation of data. So that could be cutting something in half, or in our case, a buffer, which is where you take a polygon, a point, or a line, and you enter in a certain buffer zone. So that could be however many meters around it you want. It'll be a radius. And then it'll create a new polygon that will include both the original and the added radius as one. We also have the intersect, which will overlay one set of data with another and give you an output as a new layer. And it won't do anything to the original layer in either of these cases. So we'll just have our new set of data as a third piece, and everything else will be preserved. So the first thing that we'll do is buffering. And I think how you choose to do this is really interesting. So I found 2 different articles that are also going to be hyperlinked once you have this. And I found one that does research about Palestinian liberation, and they published an article about blasts of bombs and just damage radii. And I pulled a quote that said, with a fairly generous estimation that a damage point has a 25-meter radius, the footprint of a house or the blast radius of a bomb, I chose to buffer 25 meters around the entire firing zone shapefile. And I zoomed in so you could see the difference of here we have this light line in green, which represents 25 meters. And on the right, there was a different article that was published by a different source about the damage radius of a bomb blast. And this one said it could be up to 300 yards. And I think this one might be a little bit more credible in this sense, just because they do focus the article's research on actual violent blasts. So I went and buffered 275 meters, and you can see that it's a much larger radius. They're even running into each other. So it actually looks like one large cohesive firing zone with that radius of damage. And then as far as if you actually wanted to create 2 maps, you could, but you can also just run this tool to experiment with what you actually want to use and compare and contrast differences. So you can just compare a bunch of different articles, and domestically that could be something like as simple as, plotting schools and putting a buffer zone around construction sites based on different articles about how disruptive the noise levels can be, and see which schools are caught in the buffer zone and which ones aren't. And to see which ones are in which, you use the intersect tool. So for this, I saw schools within firing zones were originally, I put that as my input, and then my overlay layer would be the firing zones. And I saw that there were 10 schools that overlapped within a firing zone. And then once I put a 100-meter buffer zone from a different article, I saw that actually there were 14, and I just circled them in red so you could see them a little bit better. Some of them are overlapped, so it's a little hard to see when it's zoomed out, but there's 4. And it really challenges you to think about your choices of scale and symbology and how you want to portray the differences between the files that you manipulate and the ones that you download. And it really forces you to base everything off of scientific evidence, or else it could be really misleading and a very inaccurate map, even if you're using the correct data. And another example would be if you wanted to do a radius for an environmental hazard like toxic runoff, you could have schools or hospitals or really any type of data. You could do recreation centers, playgrounds, anything with like more vulnerable populations. And you could plot a buffer zone of runoff from like a factory with those community buildings. So now that you have all that data, you can change all the colors, and I'll show you a simple tool that you can use to come up with a color palette if that's something that's challenging. There's plenty of resources out there. And then there are 5 main components to a map that you'll want to create. So the first thing is you want a title that's short and descriptive. In this case, since we don't want to do an inset map, it's a little bit more complicated. We're making sure to put where we're working in the title. So I put West Bank. You want to make sure that it's facing north. And we'll look in and we'll double check that our projection is correct to make sure we're using the right type of map to lay our data on top of. And I put a north arrow up in the upper right. And scale is intentionally put in the top left. So if we were doing something like population density, probably knowing how many kilometers, how far something is not the most important, but because we're looking directly at proximity of points and firing zones, we do want to put that intentionally on the top of the page. And then we also have our key, which we are going to order with the smallest to the largest. So it's going to be hospital and clinic first, and you want all these to be in the singular because you're saying one of these symbols equals 1 hospital or 1 clinic. And then we have our firing zone, and then we're denoting how large the buffer is because it's still a little bit hard to tell even with a fine scale. Especially if you're looking at it digitally, and the West Bank as our base layer. And then we have our metadata. So that's going to be pretty small because it's not really the most important thing at first glance, but you want to make sure it's there. So I've actually provided that in the written instructions. So I have Cartography by Danielle. And then you have the projection that we're working in, which again is written for you, and I'll show you how to check it. The date is really important to be accurate. So I made this on January 15th. Because we're using open source data, it can update very frequently. This data is not the most recent, but it's good to note that so that you are saying that this was accurate as of the time that I made it, and you're not asserting its accuracy after that point if it was updated. And then our sources are, of course, our credible sources from the beginning of the slides. So next, we're going to get into the demo. So at this point, I'll take any questions about like the first part, if we have any. If not, it's also okay. So I'm going to send these slides in the chat so that you can have access to the written instructions, the data we'll be downloading, and the QGIS installation. Oh, how do I get back to the chat? Oh, there we go. Okay, cool. All right. So now I'm going to show how to get, oh, good. It seems like some people are on the dock. That's good. I'm going to show how to download the, first you'll need Python and then you'll download QGIS. So you're going to click on this link here and you're going to scroll down to what system you're using. I have a Mac, so I already have it downloaded, but I would choose this one and it's going to download here and it's going to prompt you. And I have screenshots of what the prompting will look like. So, oh, for QGIS, but if you have a Mac, you may run into an issue where it doesn't want to download something new because it thinks it's a threat. So here you can either click open anyway when that pops up, or you can go to your Apple menu and you can go to system preferences and click security and privacy, and then click general, and then you'll be allowed to allow the download. You might have to put in your computer password, or if you have like a newer model, you can put your fingerprint in usually, and that should download. But after that, you can click onto this QGIS link. And you can download either one of these. I was personally having a problem with the most stable version, so I downloaded this one, but it really doesn't matter that much either way. And then of course, if you're on a Windows, you can download using this, either one of these. So then it's going to prompt a setup wizard, and it's going to look just like this. It'll be pretty self-explanatory. It'll walk you through it and you can just hit next. And you're going to select a folder to keep the application in. It's not actually where your data will be. So most computers have like an application folder. You can just select that. If not, you can hit this browse. And then it'll take a few minutes, but it'll download. And then it'll prompt you with a few extra ones. And then once you've finished it, QGIS is ready to go. And you can open it like any other app. If you were to open, your calendar, anything, it'll either load in the dock, or if you have like some sort of window screen where it all comes up on your desktop, you can click it there. And then once it loads, this is what it's going to look like. I have mine up here, and don't worry about getting the data into QGIS. We can do that together, but the link to download the data is also on this file. So you'll just click that hyperlink. The data is here. So you can download all these zip files just like we talked about in the webinar. I suggest making a folder for all that data to go into so you can get organized. It'll be easier to get into QGIS if it's all in the same place. You don't have to hunt for where your data is in your downloads. And it'll just make everything easier. And then also when you want to export your map, you can put it right back in that folder and you should be good to go. But I can take any questions. We can also take a little short break if you want. And then when we come back, we can do the demo. And I'll be around to answer questions in case the downloads are showing up weird.
I don't know if anybody else needs a break. I'm fine to go ahead if you want to show the demos, Danielle.
Okay. Did anyone want any assistance, or should I just go through the demo?
I'm ready to go. If other people are ready to go, you just download like the whole zip file, right, from the Google Drive?
Yeah, exactly.
Okay, so some people are having trouble downloading them because they don't have admin credentials on their institutional laptops. This is the story of, yes, it happens to us at GW also.
Okay, well, I mean, I don't mind going ahead and giving the demo if it's not working like on the laptops that you're using. Because this will be sent out as a video, right? So you'll be able to follow along later.
Yes, Julie said quite a few people actually log on later and view the recording. So
Okay, perfect. Then, I mean, I'm ready. So I'm just going to get my QGIS up and ready to share. There we go. All right. So I have QGIS up now. I am going to select new empty project. The absolute first thing you want to do is save everything because you don't want to lose all your work. So I'm just going to press the save button. I'm already in my West Bank infrastructure webinar folder. So I'm going to say webinar and save. Great. So now everything that I save within here will be saved. So I am going to navigate to my folder. And I am going to take my first file, which is firing zones, and I'm going to click it and drag it into my layers, and it'll pop right up. And this does look vaguely like the outline of the West Bank, so that's a good way to check that you're in the right projection. But if not, no worries, you can always go here and readjust. But we can see here that I'm in a perfectly fine projection to be in. The next thing that I'm going to take is schools. And I'm going to do the same thing. I'm going to drag it in. And the final third layer I will need is my West Bank polygon, which is right here. There we go. And you can see it loads in really randomly. So I'm just going to take this and drag it to the bottom so that everything is visible. I'm going to save my work and keep going. So of course, I'm layering everything. I'm making sure I can see everything. You just zoom in and out standardly as you would on your computer regularly. And you can use this hand to pan around. Just briefly going to right click, open attribute table, and just looking at the different attributes that the school has. So here's your object ID, and that's your random numerical order that you're sorted by. And then you can also sort, by perhaps its English name. Some of them are going to be null, which just means that they don't have one, but they should mostly have an Arabic name as well. All right, so the first thing that we want to do is we want to put a buffer zone around firing zones, just so that we can start comparing the data that we're going to intersect later. So I'm going to start by selecting the file that I want to work on, which is my firing zones. I'm going to go up to vector data, geoprocessing tools, and buffer. And that was all just single regular clicking. So here I have firing zones. If you didn't, for some reason, click it over here, you have the option again to do it here, but I just find I make fewer mistakes if I know what I'm working with to begin with. I am going to put mine at 275 meters from the second article, but if you wanted to read through a bunch of different articles and see what you think is the best buffer zone, feel free to do that, but I'm going to choose 275. You don't need to worry too much about segments, or any of these other defaults, but you will probably want to click dissolve result, which is what I was talking about earlier, where if there is overlap, it's going to merge and create one large polygon rather than showing polygons that are overlapping. And I'm going to hit run. Great. So you can see that saved over my Israeli firing zone. So I'm just going to pull it down so that it's visible. And it's lightly visible now, but we'll worry about the color later. But if you zoom in, you can see that it's definitely there. And when you create these new files based off of the geoprocessing functions, they have this little symbol here, and that means it's temporary. So I'm going to go ahead and save that. Because if I save my entire project, these and the colors there are and everything will be saved, but buffered will not be saved. It'll be a blank file. So in order to save that, you want to right click, make permanent, choose a location for it. So this is my location. I'm going to say save as buffer zone webinar. It might be too long. I'm just going to say buffer webinar and save. There we go. And then if you wanted to double check it, you could just click this and it'll show you exactly where it is inside of your files. But I'm going to get rid of that. Then I'm going to relabel it just so that I know exactly what it is. So I'm just going to say buffer zone 275 meters. And this is only going to relabel it within QGIS. It's not going to relabel it within your computer files. So the next thing that we want to do is we want to see our schools and where they intersect with the firing zones and the buffer zone. So the way that I'm going to do that is I'm going to select schools because that's what I'm working with. I'm going to go to vector, geoprocessing, but this time I'm going to go to intersection. So the nice thing about QGIS is it actually really spells out for you exactly what you're doing right here. But you want to make sure your input is schools and the overlay is going to be firing zones for the first one. And then we're just going to say open output file after running and run. And it's super quick. So now I'm going to turn off my schools. And I'm actually going to change the color and size of intersection by double clicking that icon and bringing this up, which is going to be a really important tool. So we're going to go to symbology and I'm just going to choose this white dot here because it's a little bit bigger and it'll really pop against the background. And I can see that these are the schools that are directly within firing zones. So if I wanted to open up that attribute table again, I'm going to right click and go to open attribute table. I'm going to see there's 10 here, and I might even make this window a little bit smaller so I can see what I'm working with. And let's say I was curious about one that seemed very much so in like the middle of a firing zone. So I would go to my select tool from the slides and I will zoom in and I'm going to select this school. And then when I open my attribute table, I can see that I can learn a little bit more about this school. If I wanted to, I could look it up, online. But for right now, I'm going to use this button here to deselect. So the next thing I want to do is I want to be able to compare these, the intersection between the firing zone and the buffer zone. So I'm going to relabel this intersection because the other one will also, when I developed it, be called intersection. So we want to make sure that everything is really clear and you don't get confused with your own files. So I'm going to call this school in firing zone. And press OK. I'm also going to take it and I'm going to make it permanent. So school zone. And I'm going to choose my location and save. And there we go. Now, when I save my project, everything is saved. So I'm going to go back to my regular schools file, and this time I'm going to intersect it with the buffer zone. So I'm going to go to vector, geoprocessing, intersection, and I'm going to take schools and I'm going to overlay it with buffer zone. And I'm going to hit run. And this will take a tiny bit longer because you're working with two files that you created, or one file that you created, sorry. Great. And I'm going to change this again just by double clicking, going to symbology, and choosing maybe blue will show up. Yeah. And this way you can compare where there were none before, and now there are a few little clusters of schools. So I can right click that attribute table and see that there are now 30 schools that fall within that buffer zone. And those are also going to include the ones that are in the firing zone. So there's a 20 school difference. And again, if you wanted to use your selection tool to, select multiple, I could hit 1 and then I could hold down my shift button and see what all these ones were and go back into my attribute table and see a little bit more about this cluster. So I'm going to remove my selection, right click. Another way to get to the properties window, besides double clicking the icon, would be to right click and go to properties. And here I can go and change my title again. So I'm going to say school in buffer zone and press OK. I'm also going to export this now, make it permanent. And save as is. So now I have all of the data I need, but as you can tell, it is really difficult to see some of these colors. It doesn't really make sense to have red as a background. Like cartographically, it just looks like that would be the firing zone. It doesn't really make sense. So I want to show everyone just a tool that I use that I think makes it easier to find colors to use. So it's this website called Coolors, and it's completely free, and it copies the color palettes that you want, or the individual colors from the color palettes directly to your clipboard. So you can just click on it if you like that one, and paste it into QGIS. So for example, if I wanted this sand color as my background, I just clicked it, copied it, and when I right click properties, symbology, and here for simple fill is where I can get a little bit more detail, and I'm to do my fill color and paste it in, and that'll automatically make it that sand color. And then I might want to do a little bit darker of a version for that outline. Like this. And that way you can see everything a little bit better. Another really cool thing about that website is that if I want to, I can open it in a generator, and I can lock into place. Actually, I think you have to pay if you want to do 6 of them, so remove. And you can start toying around with different colors that you would want. And you can lock them into place and it'll just generate something that makes sense. And yeah, I mean, it's meant for maps. So I don't know. I think it's a really interesting and useful tool. So I'm just going to double click and make these different colors so that it looks better on a map. I'm also going to avoid confusion by making the outline layer the same color so it doesn't look like a third layer with the buffer. And then I'm just going to make that buffer something that will really pop against it. So I might just make that even like a brighter pink or something. And then that white still works, but I'm going to change maybe the blue to yellow, maybe. And you can just play around with this. There's no real, I don't think there's a real science to it. There we go. And now you're able to see everything really easily. And you can play with the sizes of everything. But of course, this is just like the basic way to do it. And I am going to press save. And then I am going to enter layout mode. So that is where I am going to go from working within this analysis of the data and creating data to how I want to express it visually. And you can either export it as, an image or a PDF, and I'll show you how to do that. So I'm going to go to this button here with the ruler and the little star. I think it's a star. And you click on it and you'll need a title, but this won't be the actual title to your map. It'll be the title to the file. So I'm going to say webinar file. Great. So the default is usually landscape, but I don't think that really makes a lot of sense for our data. So I'm going to click just a regular click, and I'm going to go from orientation landscape to orientation portrait and zoom out. So this is the paper that we'll be working with. You can think of this as, how it would print out. So then I'm going to add my map in, and I am going to click this button that looks like a little scroll, and I'm going to place it right in the center. If you wanted to, you could place it below and have your title here, but I like to do it like this and have this just as sort of a frame, as the paper as sort of a frame. In order to move the content of your map within the actual frame of the map, you have to click move item content, and then you can click on the map and you can scroll in and out just like you normally would, scrolling in and out in the GIS analysis window. So next we have to add a title. So the way that we can do that is press add label here. And anytime you want to add any sort of text, we just press add label. And I take this and I drag it where I want my text. And it'll just give you like random Latin, and you can make it whatever you want it to be. So I am going to say proximity of schools to military firing zones. And that'll show up like that. And if you scroll down here, you can change the appearance of it. So for the font, I am going to pick Georgia. And I am going to make this a really big font because it's a very important component. It is the title, so I'm going to see if 36 fits well. And I actually will say military firing zones in the West Bank. And I will center it like a title, and that seems to fit perfectly. The next critical component I'm going to add is a scale bar. So I'm going to go here to add scale bar and click on it. Again, you're going to have this little cross that will show you where to drag, and you'll just click wherever you want it. Of course, you can always move it around just by simply dragging it. And I am going to put it at the top. And similar to the map that I had on the slides, I'm going to change the style to line ticks down. And then I am going to check that everything looks right here. The scale bar is kilometers. You could also change it to meters, and that would just automatically change it to be 10,000 and 20,000. But I think that's a lot to show. So I'm going to show kilometers. And then there's other things here that you can change. So you can put segments to the right. So showing 10, 20, 30. And then you can also have differences in the amount of subdivisions you want. So there's all these little choices that you can make, as well as putting a frame around it. And all these options are here for the text that you'll be using as well. And then moving on to the north arrow. So here is a little N, and that symbol you can click on it, and the same way that we did it before, we're going to choose where we want it and drag it here. And this to me is a little bit distracting. So, because we're pretty confident that this is north facing. It's not like we're on a map of the ocean and we don't know where we are. So I'm going to put something that I think is a little less distracting. So we can go here and slide to the right, and it has all these different options. I'm going to choose this one because I think it's a bit smaller, and place it over here. You can even move your text around if you want your north arrow to be a little bit higher, but I'm going to keep it here. So the second to last thing that we have to add is a legend. So I am going to put one here, and the legend is, again, I'm just clicking this little icon that shows these 3 little boxes with a little line next to them. And that is going to show every single layer that we have in the GIS analysis window, but we aren't necessarily using all those. So we want to click on this and call it our key as the title under item properties, and scroll down to where it says legend items. So now that we're done actually working within QGIS to manipulate the data, we can unclick auto update so that we can alter what the key looks like. So for schools in the West Bank, we are no longer using that. So this won't delete it out of the analysis window, but it will just delete it out of the key. So I'm just going to press this minus sign. And then if you wanted to drag anything around, you could here, but everything seems to be in the right order. Israeli firing zones is one word, and it doesn't really make sense. So I'm going to double click that to change it to Israeli firing zone. And that'll save. Oops. And then I am going to scroll back down to item properties and see anything else that needs editing. So you can see here West Bank polygon, double click. And, when you're looking at a map, you don't need to know that it's a polygon. You can see that. That's just more of a technical term. So we're just changing it to West Bank. And then if you want to change the font, you can also do that by scrolling down with item properties, going to font and text formatting. I'm going to make it consistent with Georgia and select that and make it size 24. I think that should fit nicely. And for the item label, that's going to be this individual item here. Sometimes you might have a subgroup or a group. Sometimes if you're showing population density, you might have different percentages that are shown under a group heading. But for us, we just have simple labels. And I'm going to go here. I'm going to also change that to Georgia and change it to something that's still very readable, but a little bit less glaring. So I'm going to put that in size 16. And then if I want to highlight it a little bit better, I can put a background on it. And I can make it something that corresponds nicely with the actual map. And I can also change the opacity if I don't want it to be so obvious that it's, the first thing that you see. The first thing you see should always be the map. And then I can also put a frame around it. So the very last and very important thing that we need to add is our metadata. So I'm going to go back to my text tool. I'm going to click on it. I'm going to drag it right below here in a place that I don't think is too distracting. And I am going to say everything that I need. So who the author is, the date, which is the 23rd of January. And the projection that we're using. And if you want to double check what projection that you are using, you can go back into QGIS. You can go into this EPSG thing here. You can click on it and it will tell you exactly what you are in. You can copy and paste that. You can open up layout again. Oh no. Okay, thank you. And then you can paste that into projection. Okay. Not sure why that's not working. Okay, well, I would paste that into projection. Maybe. Sorry. Okay, then I would center it to the right. And if you wanted to export it, you could press export to PDF. And it would just export the entire page as a PDF. So I could say final map. And it would save it like that. It will prompt you with this window here, and it will say, always export as vectors, save, and you'll open it as the PDF version here. And you'll see that it's ready to print out if you need it. If you wanted to enter it as an image somewhere, you could press save layout as PNG, or you could also, oops, my goodness. Or you could also do it as a JPEG, and you could save it like that and keep all the defaults and open it as a JPEG. And then you would be able to easily insert that as an image into a slideshow or just any other context where it can't just be like an entire page. But if anyone has any questions, I can take those.
So you said with like getting those files, like you can just search up, like I teach in South Carolina, like South Carolina shapefile, and the South Carolina Department of Transportation or something will have something of that sort ready to go. And it's
Yeah,
just,
so if you just, yeah, you can definitely do that. Like a South Carolina entire shapefile, you could, I actually just searched up as you were talking, and it looks like there is one that you can download by county subdivision and as a whole directly from the Census Bureau.
oh, awesome. Thank you.
That's a lot of really good information. I'm going to have to watch this a few times to get all those steps down. Other questions from anyone? Okay, well, Danielle, thank you. We will make sure that everybody who was here tonight and those who watch this on demand have contact information, not only for you, but also for the center, for anyone who's interested in the opportunities that Shane presented earlier. Thank you so much, everyone, for being here with us tonight. I hope you have a great evening, and good luck with trying this in your classroom.
Yeah, and my email is also